So now all the sessions from now on, right, will be recorded. So while the course is going on, you don't need to take down any sort of notes. Just listen what I'm saying, watch the screen, ask questions at any time you feel like, right? So you can watch the recording afterwards at your own convenience, download it, play it as many times as you want. And I will also share my GitHub with you, right? So GitHub is where you will find all my configs, everything. I will share that with you as well. So let me just tell you a little bit about how the course structure will be. So we will be having a live interaction every weekend, Saturday, Sunday, for the next 4 weeks, right? All classes will be recorded, and I will share the link where they are uploaded so that you can download them. You can contact me through email, phone, if any need be, in terms of any questions you have. And I will also put up a kind of assignments and kind of a quiz work for each of the module. So thing is, like, I got the email IDs of all the participants very late today, right? So I could not register them in the LMS. So I have an LMS, which is Learning Management System. So I will register them in that, and you will have access to assignment and quizzes, which will be similar to any exam you have, like for example, the Cloudera exam you have, or MAPR exam you have, right? So it will give you a pretty good understanding what will be the exam format. And also we will be doing a project, right? It all depends upon the participants, right? Because as I said, currently in the audience we have most people who are from industry. They are really very well experienced. So we can do a project according to the audience poll, right? It may be anything related to analytics, it may be related anything to databases, or it may be related to anything from the infrastructure side, right? Or from an automation perspective. So we can decide on that. So let me just walk you through what all things we'll be covering. So when I say covering, it does not mean I will be talking theory. No. Everything whichever I mention in the modules, we'll be doing a demo on that. Right? I will be showing you how to set up each every component which we talk about. So in module 1, which is today, it will be a very basic introduction to Apache Hadoop. What is Hadoop, why we need it, the Hadoop architecture, the very base, right? Today's class will be building up your foundation. And as we go along, then we will start doing a deep dive into both the operations aspects and the development aspects as well, right? So we might not be writing MapReduce code, but we will be talking about a lot of challenges, lot of business use cases where you need to know the development aspects as well of a Hadoop rather than just setting up servers, right? And we will also be talking about few NoSQL databases. And as we go along, there will be like a lot of challenges which we face in the production market, right? In the production world. So we'll be looking at all those things. For example, how you plan a cluster for, let's say, 1 petabyte of data. So we'll be looking at what are the challenges, how you plan your cluster, how you manage it. We will look at some of the important tasks which you need to do in a Hadoop, right? In a Hadoop cluster. We will also look at how you do backup recovery, how you do upgrades of Hadoop, how you configure Yarn, how Yarn is different from traditional frameworks, what is high availability. I will give you a demo on both, how to set up using Quorum as well as shared edit NFS server, right? I will show you both ways. Then we will move into little bit of aspects into for developers as well, right? First of all, we will be looking at how you will set up Hive, Flume, Scoop, right? HBase, right? And then we will look at how you can make use of them to ingest data, to work on data, right? Lot of things. And in module 8, we'll be looking at security, which will be Kerberos, right? What is Kerberos, how you set up Kerberos, how you enable that in Hadoop, everything. And then advanced features like snapshotting, NFS, right? So somebody might wonder why NFS is advanced, right? I'm not talking about NFS of a Linux system. I'm talking about NFS from a Hadoop perspective, right? There are a lot of challenges there. And in the end, if we get time, this is separately I have marked, we will talk about some of the production use cases, best practices, and performance tuning, right? What things we need to take care when we talk about Hadoop. So what's the agenda for today's session? Just give me a second. Let me check how many people are waiting to join, because as I mentioned, today's session is the first one. So most people were not aware how to join the classes. Okay. Anyways, everyone is in. So agenda for today's class, we will be talking about the basic, what is big data and what are the challenges it brings. Many people in the audience, they might find it very familiar, what things I talk about in the first few slides, right? Because they have seen those many times. And those are the common things which most people talk about. What is big data and what are the challenges? And then we will look at why Hadoop is a solution, and then we will start little bit into the technical aspects, that what is Hadoop and what it does for us, right? So Hadoop, first of all, right, when we talk about Hadoop or big data or anything, right, there are a lot of things which come under it, right? It's an umbrella term. It's not one component, right? It might be in terms of infrastructure, it might be on a cloud, on a physical nodes, in a co-location, it might be, right? It might be talk about analytics can also be of various types, right? So there are a lot of things which it talks about, right? So big data is kind of an umbrella term. So let's go one by one, and we will take one thing at a time and try to understand it, what exactly big data is. So the very common definition, first of all, of big data is anything which is too large and complex to manipulate, right, with standard tools, right? So this looks like a very simple definition, but let me explain you what actually it means. So let me just see if anyone has any questions till now. Okay, no questions till now. Okay, so let me just pull up my scratchpad. So hope everyone can see my screen and they're following. So up till now, right, it looks very good in theory to talk about, okay, data size is big, I will say it is Hadoop or it is big data or not. But let me explain you. Let's say I have a system with me, one physical server, right? Let's say its configuration is 4 gigabytes of memory, some, let's say, 2 core CPU, right? I have a file to process. Let's say file size is 1 GB. I need to process it. Process means, let's say simple, I have to do a word count, or I have to just do some search on that file. I have to just search on some characters in that file or some words in that file, right? Not a problem. Why? Because entire 1 GB file can sit in the memory of my one physical server. Not a problem. But what if it goes little bit higher? Let's say 10 GB. Can I do this on a box which is having just 4 gigabytes of memory, right? Obviously I can do it, but what it will do, it will do lot of swaps to the disk, right? So what will happen, it will load first 4 gigabytes in memory, right? I'm taking the best case, right? Although 4 gigabyte will not be entirely available, but let's say it is the best case. Next, again 4 gigabyte, and then 2 gigabytes, right? So what will it will do? It will spill to disk. Everything will go to disk, right? And then it will again read back the disk to give you a final output. So I have to do multiple IO operations for this, right? So it is not that the initially we did not have large data before Hadoop came into picture. We had large data, but most of the time what we did, we were not worried about it. We were just dropping it. Most of the things we were not capturing, right? Or we were just archiving it into a warehouse, maybe on a tape drive. But now the challenge is whatever data we are getting, we are trying to keep it live, right? So that you can work on larger set of data to get better results, right? As simple as that, right? So now, simple definition, the size of data, one factor. Another factor, it should be little bit complex for you to handle that. Yeah, sorry guys for the interruption. As I was telling that today's is the first class, so people are calling in. Okay, so now simply I cannot say that if my data is 1 GB, it is big data, or if it is 1 petabyte, it is big data, right? How complex it is to work on that data will also decide whether it is a big data or not, right? It falls in that category or not. Now another question which comes into our mind is how we are getting this data, right? So this is a very familiar slide for many people, but let me just walk you through this quickly. So how we are all of a sudden started getting so much data? One first thing is we have so many devices that are hooking onto the internet, right? Let's say a very simple case, a single user, he might have, let's say, a laptop, a desktop, and some handheld device, and maybe some telemetric devices, let's say a wristwatch which is also hooked up into the internet. So every device is now generating a lot of feeds, right? So we are getting lot of data. Also, the size of the enterprise systems have grown up so huge, right? Every year we see an exponential growth into it. They are also contributing to major data, right, which we see. Another thing is automation, right? So I do not need to worry about doing anything manually. I don't need to sit on in front of a system to do some work. We have automation in place, we have automation tools, right, which will keep on doing the work, whether you have an engineer sitting it out to watch it or not, whether you have a developer working on it or not, right? Your builds will happen automatically. It will send you emails, the logs, right, the error reports. the services will work, they will restart, they will deploy, right? Everything will happen. So that's the reason you will be getting more and more of data. Another thing will be, now the challenge is everybody is trying to use the data which is available to better target the customers. It may be in terms of any analytics, or maybe let's say any kind of prediction, let's say weather forecasting, right? Stock exchange behavior, or flight, right? For example, British Airways were the first to implement big data, the analytics part into it, to understand their customer better, right? So for example, a flight will have multiple sensors on it. For example, sensors for detecting the weather conditions, sensors for detecting the temperature, sensors for detecting the load, right? The fuel carrying capacity, right? All those things. So using these data, they can plan their better round trip times, right? From a location A to location B. And also they can serve the customers better, because now they can track what was the preference each of the customer gave for the seating arrangement, right? So next time they don't need to ask, right? And let's say a customer books it, they will try to give him the preferred seat he wanted last time, right? So all this analytics kicks in. So there are multiple use cases, you name it. It may be healthcare, aviation, research, right? For example, a very good example is Hadron Collider. It's kind of a atom smasher which is at Geneva. We called it as a particle accelerator. So it is generating huge amount of data, a petabyte of data in few seconds. So how you will ingest that size of data? You cannot just put a traditional system, one box, and say it will be taking 1 petabyte of data in few seconds. It can't take, right? So you have to design your systems which could scale to those levels. Okay. Another thing will be in India, for example, the biggest example is the Aadhaar project. They are doing millions of transactions in a day, and there are a lot of challenges they faced, and they went from one Hadoop distribution to another. As we go along the talk, we will look at why those decisions were made to switch over from one distribution to another, and how they met their latency time. For example, let's say I give my Aadhaar number and it needs to be validated. The app, when I enter my Aadhaar number into an application for verification whether it's valid or not, I should get the response back in 3 milliseconds. So in India, we have data centers in Delhi, Bangalore, and I think Mumbai they are building up. So how you take care of latency? So I will be giving you a use case on this as well, how they are doing using big data and what decisions they made. You might be doing analysis, right? Analysis could be of various type. It may be predictive, right? You might be doing a sentimental analysis. Maybe you are looking for some trending on, maybe on Twitter, maybe on Facebook feeds, right? There will be n number of use cases. Banking, for example, right? Fraud detection. How you will do a fraud detection? Now somebody might ask, Hadoop is not a real-time system, right? It is more of a batch processing system. So how we can use it for fraud detection? For example, let's say I'm a user. I swipe out my card, right, at a location A, and my buying pattern, or my, if I look at my credit card statement, my behavior will be something $10, $20, $17, right? But all of a sudden, there's a swipe of, let's say, $1,000 on my card. How will you find out, is it a legitimate transaction or somebody has misused my card? So you have to build intelligence into your system, right? So we will be talking about few use cases in this as well as we go along. stock exchange, right? So n number of use cases will be there. So data is growing at a very rapid rate. So our traditional systems, the traditional models which we had, they don't work, they don't scale, because every data we are trying to capture, data was always there, sensors were always there, multiple sensors we had wipe devices, we have enterprise data storehouses, everything was in place. But now we are trying to capture it so as to gain an competitive advantage in the market from whatever data we are getting, right? So that is the most important thing. This is a very common slide which most people might have seen, the three V's of big data. So this is originally published by IBM, the three V's of big data, which is volume, velocity, and variety, right? So let me quickly explain you this, what it is. Volume is straightforward, the size of data, right? Velocity is how I am, how my data is flowing into my system, right? Is it a batch process? It is real time, or it is streaming data, or it is coming at multiple instances. For example, let me give you an example. Let me see if anybody has any questions in the meanwhile. Okay, no questions. So let's say, forget about Hadoop for some time, right? Because we have not yet reached there. Let's say I'm a simple administrator in a company. I have a server on which I have some hard drives, right? On which I can store some data. This box has some CPU, some memory, using which it can process the data which flows into it. Now, how my data is flowing, right? Let me give an example. Let's say I have 10 GB of total data, right? This is my total data, right? Total size remains 10 GB, but is the entire 10 GB flowing at one time, let's say 1 a.m., or it is 1 GB every hour, right? Or it is 500 MB maybe every half hour, maybe 1 MB every minute, right? My total data might be 1 GB at the end of the day, in the last 12 hours, but what is the influx of my data? It might have different flows. So I cannot use a traditional system. If my data is less, it's fine. But if my data is growing, I cannot say, if my files are small, I will use node A. If my files are big, I will use node B. And if they're very big, I will use node C, right? So I have to build multiple environments, heterogeneous environments, which they don't talk to each other. So it will increase my complexity. If I have to query data, I have to write complex queries, right? I have to take care of shards and all, right? For example, for the time being, leave what shard is, we'll talk about it. So there will be a lot of challenges. This is velocity. Another is, another aspect of velocity is whether it is a batch processing or real time. What is batch means? I get data, let's say 2 GB of data now, I process it. After 1 hour, I get 2 more GB of data. Now I combine 2 GB and 2 GB, batch it, process 4 GB, make some decision, right? Real time is the moment data flows in, I'm processing it and taking a decision on it. Decision means I might be writing a file, I might be writing an output, right? So there could be n number of cases in this. In Hadoop, uh, currently there are a lot of use cases in which companies are trying to use Hadoop for real time. Although Hadoop is not designed for real time, it is designed for batch processing, but still they are trying to use it for real time. So I can give you use cases for that if somebody is interested, maybe later on. A variety of data. My data could be simple text files, they can be images, they can be movies, right? They can be JSON. So I cannot say I will build 4 clusters, one cluster for text data, one cluster for JSON, right? Or one cluster for images. I should have a platform which is common to all the problems I have. And I should be able to scale it as quickly as possible, right? So we have seen few of the challenges. There are n number of challenges. Okay, let me ask you and get the audience interactive, because people are not asking any questions. I can understand currently. I have the slides which I have gone through. Most people have seen them, but let me ask a very simple question. Let's say I go to a Facebook page and I click the like button. Do you think how much traffic it might generate on Facebook? Can somebody give an idea how that might work, or what could be an like doing, what kind of a call a simple like might be doing, how much data it might generate? Any idea? Raj Rai Guru is saying no. Okay, I did not get what no refers to. So my what I was trying to ask, let's say I simply go to my Facebook page and click the like button. Very simple operation. Do you think how complex it might be? Right? Not from just from the code perspective I'm talking. Let's say if you are simple infrastructure guy, how much traffic that could generate, or how much data that a simple like could generate? Rohit is saying behavioral targeting. Okay. Okay, let me take that one. Just give me a second. Let me just double check no one else is waiting to join in. Okay, we have almost everyone in now. So Shiva joined just now. So we are just going through the very basic stuff, right? What is big data and all. We have not yet moved on to the Hadoop part. So I was explaining at the beginning of the class that all the sessions we will be recording, right? So if let's say if somebody misses any session by any chance, right, they can download the recording. I will share where to download it from, and they can watch the recording, right? So they don't need to worry about taking notes or anything. Okay, now coming back to my answer on this one, right? So big data is just one part. Hadoop is just one part of the bigger picture, of the bigger complexities, right? For example, let's say I go to Facebook and I click the like, somebody's like. It is a simple AJAX call, 4 byte AJAX call, simple AJAX call. But what will happen? I will have a network of people who are connected to me, right? Let's say this is my account, multiple connections, right? Multiple connections. This is kind of a graph DB. Now I might have put up lot of filters. Let's say I may have 1500 Facebook connections. To whom all this should go? Whether it should go to 100 users, whatever I like, whatever updates I send, whom should I go it go to? Or let's say this user updates something, should I get that? I may be following, unfollowing, right? So a simple like, which is just a 4 byte AJAX call, might generate large amount of data depending upon how this tree is laid out, how your connections are laid out, what filters you have put in between, right? So at the upfront, we might think, oh, it's a very simple operation. So as we go along the course, I will show you a few use cases from a developer perspective as well. When a developer goes and writes any application, if you don't take into the considerations of, let's say, the scale of data, your codes will not work. Your code will crash. It will just give code dumps, right? So we'll look at those things. Okay, Meenakshi is saying it will track person's interest and accordingly ads will be further displayed and related suggestions might be taken. Yes, that's correct. So Meenakshi is talking from the perspective of advertisements and all, and a lot of other data will be there. And Ronak is also saying a small click might generate a lot of data. Okay. So now the question comes, okay, we have seen the problems. One is the size of data, variety of data, different flow of data, and above all, it's not I have to just store the data. I have to process data. I have to work on that data and make the best decision possible, right? More data I have to work with, better will be my decision, right? Let's say if I'm trying to run any kind of predictive analysis on, let's say, 1 MB data, it will predict me something which will rarely be accurate. But as the size of data goes, if I have more sets to play with, more data sets to play with, more accurate my prediction will be. So now there's a need for a platform which can address all these challenges. So we say Hadoop addresses these challenges. How Hadoop addresses these challenges? Let me show you an example here. Very simple example. Let's say I want to write 1 TB of data, right? How much time it will take for me to write a data? I'm not talking about processing in the memory and running MapReduce and all that. Forget about all those stages. Let's say I want to write 1 TB of data and I have one system with me, one node, and I want to write that data into it. How much time it will take, right? Let me give you a little bit of background on the nodes. Let's say I have one node. It has a SATA disk. For the time being, forget what is SATA, SCSI, right? SAS and all. We will look at that in our cluster planning. So SATA is a serial attached disk, right? Transfer rate is usually around 100 megabytes per second. One disk will have a data transfer rate around 100 megabytes per second. So let's say I put 4 disk drives into that system, right? Now 1 TB of data I have to write. Each hard drive can accommodate 250 gigabytes of data per disk, right? So let me explain you this one on the board. One TB of data I am dividing into 4 disk drives, right? In a system I have 4 disk drives. So now each disk will have 250 GB of data, right? And my speed of my disk is 100 megabits per second, right? So what will happen? best case, right? There will be other lot of complexities, right? System might be using other things, doing other operations, but let's say the best case, it is just doing a read write, right? Let's say it's simply doing read. It can read all four disks in parallel, right? All four disks in parallel, each 450 GB. So 1 TB of data, how quickly I can read it? 100 megabits per second is the speed. Divide by this. Let me pull up a calculator. Right, 250 GB into 1024, this much MB. Why I'm making MB? Because the lower one denominator is in MB. Divide by, sorry, 250 into 1024, divide by, I think I've done something wrong, 250 into 1024, divide by 100, this many seconds, divide by 60, 42 minutes. So for approximately minimum, it will take 42 minutes for me to write this much data, 1 TB of data in a system which has 4 disk drives. This is the best case. What if I now, instead of having one node, I put 10 nodes? Each node has same 4 disks again. Now total I have 40 disks, right? So this factor will again reduce by a factor of 10 now. Now I can read in 4.5 minutes. Correct? Now if I put 100 nodes, same number of disk drives per node, 4 nodes, 4 disks per node, total 400 disk drives, right? And I can read much quicker, right? So the last line, per disk, will not come here. So I think this is a typo I have done here. But total data is only 1 TB. So if we keep on distributing the data, our speed will improve. So 42 minutes, 4.2 minutes, 40 seconds, right? So this is what distribution is doing. We are breaking the data. Now, question comes, what is Hadoop? First of all, Hadoop is not a tool. Very important thing to understand, right? Hadoop is not a tool, it is a framework that allows for distributing processing of large data set across a collection of commodity computing computers. So I think many people in the audience will not agree to my statement, right? Because I said uh, commodity hardware, right? It is a misnomer. So when I say commodity hardware, it does not mean desktop, right? So we'll talk about this in our cluster planning module, which is module 3. So when I say commodity hardware, it does not mean I will take my desktop and put into a Hadoop cluster, put a Hadoop on that in a production environment, right? Because there are a lot of reasons for that we will not do. But first of all, it is a framework. It is not a tool which processes distributed data. Why it is a framework? Because Hadoop is not just one part. It has a file system. It has some brain, right? Which we call the processing model. And you can plug in a lot of things. Maybe you might plug in Hive for querying it. You might plug in a database, NoSQL DB, for example, HBase. You may use Flume for ingestion, Scoop for data ingestion, Mahout for machine learning. So you can plug in the tools into it, right? Plug in various components into it. It's a framework. So as I was saying, hardware is cheap, but it does not mean that you will run on a desktop. So this diagram I have taken from Yahoo's blog. So this is how your typical rack will look like, right? Each rack will have 40 servers. I'm giving example from Yahoo. Each rack will have 40 servers, right? And you will have multiple racks. So for example, Yahoo is currently running the largest cluster of 4200 nodes in one single Hadoop cluster. And there will be a lot of things, right? A lot of things. When you talk about the planning part, let's say you are a Hadoop admin, you have to think about a lot of things. So Hadoop admin also has a lot of job profiles. So I will come to that little bit later. But little bit about the history and the users. Today, any company which is into e-commerce has a customer base or is planning to do any sort of analytics is into Hadoop. Yahoo, Google, Morgan Stanley, JP Morgan, IBM, right? Everyone is into big data. But out of these, the major ones are, which I have to point out here is one is Google and another is Facebook from a Hadoop point of view. Why? I will tell you that. It has to do with the history, right? Quickly, let me quickly walk through it. How Hadoop started, first of all. So there was a project called Nutch. It is still there, available under Apache. You can go and download it and use it. It is an indexing platform, right? Similar to kind of a Storm, right? But a very old version of Storm, you can say. But a lot of things differ. So Nutch was a project by Doug Cutting and Mike Cafrela, right? So they were working on Nutch, and their main aim was to index the web. So they wanted to index a web in which they can query all the pages which are on the net. I'm talking about 2002 time. During that same time, Google came with two interesting papers. One is on GFS, which is Google File System, and another is on MapReduce. So MapReduce is not something new. If anybody is from mathematics background and linear algebra and all, MapReduce has been there for a long time. But thing is, it was never perceived as a processing or a programming platform for computing, right? Functional programming models and all, right? It was never perceived from that point of view. So when Google came out of with these two papers, they are publicly available. You can go and read, download them. Obviously, they will not publish the code, right? They will publish the architecture, the logic, but they will not tell you the code. So what Doug Cutting did, he took those papers, rewrote the nudge, and rewrote DFS and MapReduce support on that. So I'm saying DFS here. He cannot call it as GFS because it's a Google file system. He cannot use the name Google here. So he called it at DFS, distributed file system. And it went on, right? So whenever you are working on a project and when you have a small team, let's say one person, two-person, right? The development will be very slow because there will be a lot of hurdles, lot of challenges. How much you can fund an infrastructure or anything from your own pocket, right? So the development process will be very slow. So what happened during that time? Yahoo kind of approached Duck Cutting, right, with the idea of promoting what the product he was developing, right? So Doug Cutting joined Yahoo, and that was the main thing where the development of Hadoop started. So there was a new project which forked out of Nutch and was given a name Hadoop, right, around 2006 time. And Yahoo already have a lot of servers with it, right? They were already running a very big infrastructure. So he got a platform to test out his logic, test out his code, test out his DFS and MapReduce systems, right? So obviously, whenever any product comes into the market, nobody will just blindly go and use it unless and until they see a business case for it, right? Business case means end of the day, it is a return on investment. So a lot of benchmarking use cases or studies were published. For example, some companies saying we process around 4 terabyte of data in short span of time. So various benchmarkings were done, right? So this benchmarking is quite old. I'm talking about 2008 era to explain you the Hadoop point, right? So now the same sorting of a terabyte of data is, I think, done in 6 seconds, I guess. So when all these benchmarks started coming out, so it kind of gained a traction in the market, right? People started looking, oh, there's some new tool, okay, let's look at what it is, what it is talking about, right? So during that time, few companies forked, right? So this product, which was in development in Yahoo contributed to Apache, right? Under the Apache AFL license, Apache Foundation license, right? So if you go to Google and search for Hadoop, it will take you to Apache site, right? So it's freely available. Anybody can download it, modify it, use it, develop tools on top of it. So what these companies did, like companies like Cloudera, that was founded in later part of 2008, they took this Apache Hadoop, developed tools on top of it. For example, Cloudera Manager is a provisioning tool, Impala, right? A lot of other tools, right, which will help an enterprise to use Hadoop. Because when we go and try to use Apache Hadoop, first of all, you need a team who can understand Hadoop, who can go and modify each and every file and put a parameter. Again, it will take time, money to find people. So these companies, what they do, they make Hadoop enterprise class. So enterprise class does not necessarily mean that the product is technically superior. It does not mean, right? It means it is more convenient for an enterprise to use it. Reasons could be many. It might save time for them, or they might not have the resources or the skill set to implement an open distribution of Apache. And going along, a lot of companies were found. For example, Hortonworks was forked out of Yahoo. Mapper again is formed out of funding by Google. So there are n number of distributions for Hadoop. For example, Intel, Pivotal, DataStack, right? There are n number of distributions. But the main three vendors for Hadoop are Cloudera, Hortonworks, and Mapr, right? So Cloudera and Hortonworks are purely based on Apache Hadoop, the original Apache Hadoop, which was checked in or contributed by Yahoo. These companies took that, built tools on top of it. Ambari, Cloudera Manager. We'll look all this, right? So you can skip these buzzwords I am talking about. We'll look at all these things. And a mapper. Mapper went little bit on the other way as compared to the other two companies. They developed, they took Apache Hadoop, but rewrote a lot of things. They rewrote the file system in C, C++ to gain better performance. So there are market statistics, right? So Mapper, for example, in terms of read write throughput is much better than any other vendors, right? But again, right, blindly putting a file system does not make it better. For example, the common misconception people say is Linux is more secure as compared to Windows. No, right? You have to implement certain practices, right? So similarly here. So we'll be looking at all these details as well. So now this is a very interesting slide. And as I told in the very beginning of the class, I'm a very straight forward kind of a engineer, you can say. I've been a techie throughout my life. So I don't give diplomatic answers. So we have these beautiful graphs which come always in the market, right? Showing projections of the job market and showing how big data is doing, how Hadoop is doing, right? No doubt they're doing very well. No doubt, right? They're doing very well. right? Lot of open positions in the market. It may be service engineering, maybe development, analytics, data science, right? But important thing to understand is how a demand is created in the market. It is similar to any demand of any entity. For example, any commodity product, how a demand is created for it. Either more people are asking for it, or there is shortage in the supply of that thing, right? That's why the demand increases and the price goes up. Same is the case here. So you need to understand, when we say there are a lot of open positions, right? So you need to understand there is a shortage or open positions for the talented and the skilled people, not necessarily for the workforce and certified people, right? I may sound very rude, but that is the fact, right? You need to understand that you cannot, any field, not only Hadoop, right? Especially this trend is very common, which I've seen in India especially. You see a Hadoop or a big data institute coming up at every corner in the country, right? And they are giving kind of a wrong projections to the students, right? The people who are from the industry, like most people who are in the audience, they will have no problem. They understand the industry. They can, they have been in the market for a very long time. But youngsters, they don't understand, right? They will search on Google and say, okay, what is the highest paying job? And they will say, okay, let's go for Hadoop, right? So it's very important to understand that, right? Setting the right mindset. So that's why I say in my blogs, if somebody follows that, what is the most important thing is having a solid foundation of whatever you do. I'm not talking about Hadoop. Whatever you do, whatever field you are in, have a solid foundation. That is the most important thing. So that is the main aim of our course, right? I am not here to, let's say, just talk about, for example, some buzzwords, run through slides and go. We can, I'm ready to even extend it beyond our scheduled sessions of, let's say, 4 weeks, if somebody is really interested to explore it further. Not a problem with that, right? But we should first of all understand the fundamentals, right? And this is, I'm talking from experience, right? So I have a few of my colleagues also in the audience, and they can vouch for it. Currently we are struggling to find Hadoop peoples in the market. You interview them, they will not be even knowing the basic stuff. So that is the mindset, right? So you should not be looking, doing anything or learning anything with a goal of getting a job or a highly paid job. Nothing like that. You should be doing something to get your concept or the base right, right? So with that, let's start into the Hadoop part and take things one at a time and do deep dive, right? So today we will not be doing deep dive. I will be introducing you to few things. I will be giving you kind of a work to work on at in your free time, and come prepared from tomorrow's class where we'll be doing a deep dive. So before we go into deep dive, we are almost 1 hour into the class. Let's take a quick break, grab a tea, coffee, or a water, and I will also grab a cup of coffee. And we will be back in exactly 3 minutes, right? It's 7:09:07:9:10. We will be back. So please grab a tea, coffee, water, whatever break you want, and then we will continue, right? And I will start touching the technical aspects from here on, right? And I will probe a lot of things, right? And I will ask, try to relate those things into how Hadoop uses it, right? And this way, because my main aim of asking questions is not to, to know whether you know it or not, because you will cross question me and it will help in building my knowledge, right? So let's meet after 3 minutes. Okay, so let's resume. I hope everyone is back. So I can see a question here in the audience from Bipin Preet. So Bipin is asking how Hadoop differs from big data, right? And he's saying, I got Hadoop is a framework, but what is big data? Okay. See, big data is kind of an umbrella term, right? When we say big data, it covers a lot of things. Lot of things means Hadoop, the Hadoop framework, data science, analytics, right? Big data is an umbrella term. So it's not that you will say I'm using big data, right? Companies, they use the term, they say we are into big data, right? Because it looks cool, right? Most of the companies, they will say we are into big data, but they might be using a small part of it, maybe HBase, maybe Hive, right? Any kind of NoSQL. So big data is a buzzword which was coined to represent the collection of technologies we have, right? Hadoop is a framework, right? Which in which we will, as we go, we will understand Hadoop is the real thing. If somebody asks where is big data, do you have big data installed somewhere? So big data is more of a logical entity, right? But Hadoop has a presence, right? Hadoop is more of a component. You will say, okay, I have Hadoop installed, I have Hadoop component setup. You will not say I have big data installed, right? So I hope that clears it. It will be more clear as we go along. So now, first of all, let's go one by one and understand what Hadoop is. The core, as I said, Hadoop has a lot of things, a lot of tools you can add. And as we go along the course, we will keep on adding tools. But the two main components are file system, right? Because you need to store data. The data which I put into a Hadoop system, or let's say any box, Linux box, Windows box, I need a file system to store it, right? And I need some logic to process that data, right? I need some programming model to process that data. So we have two parts. One, file system, which is called HDFS. H stands for Hadoop. DFS has come from, which I have shown you the history, distributed file system. So it becomes Hadoop distributed file system. Map reduces the programming model, right? So now let me ask you, I told you some statement, right? I said Hadoop is a file system which we need on any system, right? Linux, Windows, whatever. Can anybody tell me why we need a file system? Can't we write data without a file system? Why we need a file system? Right, so many of you might have installed operating systems and all, and before the operating system is installed, it first formats your hard drive, lays out a file system, and then installs on top of it. But do you think file system is mandatory to write data? Rohit Kulkarni is saying store data, read whenever we need. Okay, okay. Ronak is saying for faster retrieval. Okay, okay. So we have 2 points. Rohit is saying store data and read it whenever we need. So Ronak is saying for faster retrieval. Okay, I think those two answers we have. So let me give you a little bit background on this, or the history of how all these things came into picture. Right? Let's say I have a hard drive. First of all, if I want to write a data, I do not need a file system. right? You might be saying what I'm saying, right? We do not need a file system to write data. But let's say if I do not lay out a file system on a hard drive, I write something, how will I find out where it went, right? Let's say I have a book, I have an index of a book, right? I may have all the data in the book, but if I want to find it, I have to go by index. Okay, book is a very small example. I can just go through the pages, but on the disk, how will you find where the data went? So file system is very important from a read perspective, from a faster retrieval perspective. We can write data without a file system. Many systems do that. SAN does not have file IO, it does block IO. For example, there are many people in the audience who are from system background. Whenever we configure a crash dump is a process. Whenever a system, running system crashes, it writes the content of a memory to a predefined location on the disk. Solaris, OpenVMS is doing it beautifully, used to do it beautifully. It is still there. Let's say on a hard drive, I define some sectors, some location, right? And I'm running a system with 32 gigabytes of memory. System is up and running. All of a sudden system crashes. Can it write 32 GB of data in few fractions of second before the system goes down? How I can make sure it does not go through the overheads of my file system? So what we do is we predefine the location. We say to the Linux kernel or a Solaris kernel or a VMS kernel that you just dump at this location. It bypasses the file system, dumps it, but when we need to read it, we know where it was, where which locations it went. We'll go there and read it, right? So now Hadoop HDFS is also simply a file system. Now let's look a little bit deeper into it, right? Before understanding Hadoop HDFS, let's go a little bit into the traditional file system. How a disk is laid out and how data is stored. Any system, whether it's a Linux, Windows box, right? I have a hard drive in a system. I will partition it. I will format it. I will install an operating system, write some data, right? So it will have a master boot record, which is called MBR, right? Which will tell me kind of a structure, which will tell me, okay, where all my partitions are. I will have a file allocation table, which we called as similar to index of a book, which will tell me that file one went to these blocks. Inodes is a term which is used in the Unix world, Unix Linux world. In the world of Windows, we called it as file allocation table. Inode means the same thing. So it's a data structure or pointers which point saying this particular file is on these locations, right? So this is how it points. Let's say I have a file music.mp3. It says it is on inode 23456. So I will have some metadata. Metadata means the MAC time, right? Modification, access, and creation time, timestamps, who is the owner, permissions, size, and where the actual contents of the file are. It will be pointing to hard drive, right? Now, what is the difference here? In Linux, Windows, whatever systems you have, your this metadata, which is telling you where the blocks are, and the metadata itself, they sit on the same node, right? They sit on the same node. So data and metadata of a file system will sit on the same disk, right? Not even just same box. I will, let's say if my system has 3 hard drives, each hard drive will have its own metadata, its own super blocks, unless and until obviously they are not in a RAID, right? They will have their own metadata and data, which will sit within the same disk. But in Hadoop, this differs a little bit. In Hadoop, what we do, instead of having data and metadata both on the same node on the same disk, what we do, we have given a separate node to a metadata. It stores the entire metadata on one node, and your actual data goes on some another nodes. We call them slave node. So the name node is called the master node, which will store all your metadata, and your data node will be called your slave node, which will actually store your data. Right? So let me explain you this, how it will be. Let's clear the screen. Shiva is asking 3 disks, 3 metadatas, or metadata depends upon the number of file systems. Okay, yeah, so that's correct, right? So obviously, so what Shiva is saying, I use the statement that if we have 3 disks, it means 3 metadata. Not necessarily, right? I may have a one disk which I have partitioned, right? Let's say I have a Windows partition, right? And I have C drive, D drive. I will have a common super block, but I will have a fat file allocation table for each partition, right? So it will be multiple. It can be more than the number of disks, right? Or the number of the file systems we have. Okay, now coming to the Hadoop part. So what is a metadata first of all? Let's say even in Linux, when I say a file, let's say file1.txt, how the metadata will be? It will be saying who is the owner of the file, what are the permissions of the file, right? And timestamp, and then it will point me to the blocks of the file, right? This is what metadata is, right? So now, in as I said, traditionally everything was sitting in one node, one particular file system on the same system. But now what happens? This metadata, which says, let's say I write a file to Hadoop, it will say file1.txt whose owner is XYZ, whose permissions are this is the timestamp, and this is the size, has block B1, block B2, block B3, right? It will tell me what blocks are mapped to it, right? What blocks are mapped to it, right? Let's say file f1.txt. It will tell me all these parameters, owners, permissions, time, size also, right? There's one size also. It will tell me all these things here, right? And there will be one more thing it will tell, which I will tell you later, which is called replication, right? It will also tell me something called how many times each block is replicated, right? So it will having a R factor here, but it will say B1, B2, B3. And where B1, B2, B3 will be, they will be on slave nodes. Where will be block B1? It may be on data node 1. B2 may be on data node 2. B3 might be again on data node 2, right? Right? All these will be on one meta node. Right? So this is what we will be understanding in the slide. So let me explain you one by one what it is. Metadata will reside in the memory of the name node, like any other system. Let's say on a Linux or a Windows box or any other box, if I need to work on a file or a process on a file, it must be in the memory. I cannot work on a file which is sitting in a secondary storage like disk. It has to be brought into the memory either by a DMA call, which is direct memory access controller call, or some other mechanism, but it must be in the memory. So what is happening? The entire metadata of my Hadoop cluster will be handled by my master node, which is name node, and it will sit in the main memory of the name node, right? It will never be swapped out to the disk. It will never be swapped out of the disk. When I shut down my name node, it will be persisted to disk, similar to any other database concept. For example, I'm running MySQL. It will have a bin log. The moment you keep on writing, it goes into bin log. After some times, it does a checkpointing, writes into a database or commits into a database. Similar thing Namenode does. So Namenode also maintains a journal, right? Which we called it as kind of an edits file, right? So today I'm just giving you a kind of an introduction, a glimpse of things. From tomorrow onwards, we will take one thing at a time and see all the technicalities into it, right? All the details into it, right? But let's, as a building point, start point, let me explain you things one by one. Now, I said name node will store the entire metadata in the memory of itself, right? Name node, entire metadata will be sitting there. Obviously, now how big my metadata could be? Obviously, limiting factor will be the memory I have on my name node, right? RAM, the amount of RAM on I have on my master node will decide how big my cluster will be, right? Quite interesting thing. Can I have 10 nodes, 100 nodes, 1000 nodes? Will be decided by the memory on the name node, right? So I will give you this of a kind of an assignment for homework for you. I will at the end of today's session, and we will talk in detail about this, right? What does this mean? So now let's say if I have 4 gigabytes of memory on the name node, obviously I cannot go beyond it because I cannot swap my metadata onto a disk. So my cluster will not go beyond that. It cannot have more files than what my name node can store in the memory, for what metadata it can store in the memory, right? So now what is happening, whenever we write anything to Hadoop cluster similar to any database, first of all it goes into a journal file called edits, right? All these details we will see tomorrow, and it will be committed to another file called fs image, which is file system image. So what happens, whenever we write anything, any changes, they go to a journal file edits, and edits will commit to a file called fs image on the disk, right? How it will commit, when it will commit, lot of concepts are behind that, right? But for the time being, it will commit to the disk, and when it starts back, it will read the fs image file, and it will know what all files I have. Now, another thing, important thing which I mentioned in the explanation which I gave in the last slide, last means last whiteboard, I said what namenode will tell. Namenode will say, I have a file whose name is file1.txt, owner, permission, timestamp, size, replication, and it will say an array. It will say, I have a list of blocks B1, B2, B7, any block. It will say this file is on these blocks, and this is persisted to disk in fs image. Whenever we shut down a name node, and there's a concept called checkpointing. Whenever checkpointing happens, edits journal will be emptied, and it will be written to a disk, on the disk hard drive, in a file called fs image, right? But now the question comes, name node is saying this file has blocks B1, but how it knows block B1 is on which data node, right? Let's say I have a name node and I have data node D1, D2, these are all data node, right? Now in the metadata, this metadata which it has, it nowhere says anything about data node. It is only saying it is B1, B2, B3 block. So to handle this, name node has a second kind of a metadata. So name node has two metadata. One is file metadata, this one. Second metadata is called bitmap. So in the audience, I have people who are from OpenVMS background. So it's the same concept which Hadoop uses. It's called pigeonhole bitmap, right? So what it will do, there will be another metadata which will map the blocks to data node. It will say B1 is on D1, B2 is on D2, and B7 is on D3, for example. So there will be two metadata, 1, 2, right? So this is what we are explaining here. So metadata is, one is list of files, list of blocks for each file, then list of data nodes for each block, file attributes and access time. Correct? So now what it is telling me, I have a block B1 for this file, but where is B1? It is on D1. B2 is on D2. B7 is on D3. And the interesting thing is, this metadata, bitmap which I am talking about, it is only in the memory of the name node. Only in the memory of the name node. It is never persisted to disk. What does it mean? If I shut down my master, shut down my name node, this thing, right? This thing, it will go to disk. It knows that. But which blocks map to which data node? It will not know. It will wait for data nodes to advertise to it, right? So what happens? I have a name node and I have data nodes, right? So data node will have a daemon which is called data node daemon. So we will all see. So name node will have a daemon called name node daemon, right? A process running. Data node will have a daemon, a process running called data node daemon. Whenever a data node starts, it advertises all the blocks it has. Let's say I have 1 terabyte disk divided by the block size, n number of blocks. So data node 1 will say I have n number of blocks. Data node 2 will say I have n1 block, n1 number of block, n2 number of blocks. Name node will now know what is the capacity of my cluster, and it builds the bitmap dynamically. So B1 it will map, it will say, okay, B1 I have got from D1. Now I map it. So this is called block report. Block report is maintained by data node, the slave side. And every time it boots up, it sends the block rate report to the master saying, these blocks I have. And on the name node, when it is receiving the blocks, it is just building this map. It is saying, oh, I have got B1. Oh, it is coming from D1. Let's build my map. B2, oh, it's coming from D7. Let's build my map. So it builds the map, right? So now, lot of details in this also, right? We will see this as we go in the session. We will be, as I told you, few people joined late. So what things we are talking in theory, it's not just on the slides. I don't believe in those things. We will be looking at each thing practically on a box. When I say you that name node stores metadata, so I should prove it to you. I should not just say it, right? How will I make you understand that it is true, right? So if I say name node stores metadata and actual data goes to data node, right? For example, as in the slide, metadata will be saying this file has these blocks, and these blocks are on data node, right? Let's see. Let's write to Hadoop, right? So for the time being, don't worry about how we have set up Hadoop. We will be starting Hadoop setup and all from tomorrow's class. But let me give you a feel of the things we do, right? So now I will try to explain you the concept which we have discussed in theory, that metadata is on a master, actual data goes on data node. How we are setting it and all is a different part. We will see that later, right? Just to keep your thought process running for your tomorrow's class. right? So let me give you a feel of Hadoop cluster. So as I said, I try to run my setup as close to as possible to the production. So obviously I cannot have as much data as we have in production, but this is the infrastructure I'm running. I have three nodes running around 14 to 16 instances, virtual instances. I have total about 56 gigabytes of memory, right? And I don't believe in giving shortcuts or things like saying, oh, put this, it will work. Anyway, it will work. I will explain you why it works or why it doesn't work, but I will give you the actual things, how it runs in production. Setting up of a DNS, why DNS is required for running Hadoop, right? Important thing to understand. I will tell you how you configure high availability. I will have for distribution for each component. MySQL, Hive, HBase, Flume, Nagios. I have my own NAS filer as well. I've configured auto provisioning also, right? But that is as you are for a Hadoop course. So I think that will be too much. Or if we talk about how to provision Linux boxes automatically, right? I have a cobbler, PXE boot setup, and a Puppet configuration, which automatically deploys nodes for you. But we are here to learn, so we'll be doing things manually, provisioning part, right? So let me show you my box and the concept which I was talking about, right? This concept, whether it is true or not. Okay, so let me show you what things you need. First of all, from tomorrow onward, right, we will be starting our hands-on practicals and all. So what you need, first of all, it will be good to have a system with minimum 4 gig of RAM, right? Linux runs best on Hadoop runs best on Linux machines. Windows is also supported, but I don't recommend, because if you are running Windows, it itself has its own footprints, right? So currently, for example, I'm running Mac. In Mac, I am using virtualization. Virtualization using VirtualBox or VMware Fusion. VMware Fusion is VM Workstation. So it is called Fusion in Mac. So you can have base operating system as Linux, Windows does not matter. But the node on which you will be running Hadoop should be Linux, right? Install a virtual machine inside VM, VirtualBox, doesn't matter. Which Linux you use does not matter. Red Hat, Fedora, CentOS does not matter. KVM, Zen, what you use does not matter, right? So in my case, I have enough resources, enough RAM, so it's not a problem with my setup. But for your case, to do all the practicals which we'll be covering in our class, good to have 4 gig of RAM, right? So let me show you all these things. So this setup which I have is in my local laptop, and I have one server, a bigger box where I'm running my other lab, right? So this box which I have has around 16 gig memory, right? The Mac which I'm running on, 16 gig, iCore 7, right? And it runs very well on Mac, right? And other box which I have has a 32 gig memory, to which I will SSH during the classes and all with to show you all this. So for example, let me start the server, right? All those things I will explain you what each server is doing, but I'm just trying to explain you what things we I will be showing you in the class and how you will be using it. Okay, I'm starting my virtual machine, right? And I am also using VirtualBox, because see, I don't say do piracy. It is your wish, right? VirtualBox is free. So that's why I'm using VirtualBox also, so that the participants, they have a choice. They want VirtualBox, VMware, Workstation, whatever, right? This is a free tool from Oracle. here I am configured so many nodes, right? So we will configure all this. Don't need to worry about, right? But let me just give you a demo about a feel of Hadoop cluster, right? For let's say I have 4 data node, but let me start only 3. Right. In the meanwhile, let me see anybody has any questions here. Okay. Okay. Notes are coming up. Give me a second. Right. So in the audience, we have people who are from system admin background, developers, admins, right? So, but I will try to maintain the class flow, thinking that uh, people they are not from, let's say, a system admin background, right? So you can ask me things if you're not familiar with, but also to safeguard on the time and all, right? So we have to do a right mixture, right? So we will be mostly concentrating on Hadoop, but if need be, I can show you what other things are in. For example, I've configured one node which is my repo server, right? Repo server means whenever I install any RPM packages, I don't use DVD and all that. I just do yum update, and I've dumped all my packages in one node, ls-l slash var ftp pub. If I ls on this directory, you will see I have a lot of packages here. For example, CentOS 7 RPMs, Ganglia RPMs, my GitHub, Hadoop packages, a lot of things, right? Similarly, if I SSH to another node, which is another big repo server I have, ls-l slash var slash ftp slash pub, I have all repos locally set up. For example, for Cloudera, I don't go to internet, right? Everything is set up locally. Hortonworks, Mapper, right? All distros I have locally configured, right? So as the course flows, I will show you all these things. But whenever I say yum list or anything, it doesn't go outside my network because I have set up all my servers locally, right? cd slash etc yum dot repo, right? All these things I will show you. rm-rf centos. Let me just delete this. Yum clean all yum list, right? Right. So all are coming from my local server. Which local server? Cat server, which is this box itself, the box I'm sitting on. Right. IP is 254. I've set up a repo here, right? So all these things I've shared how to do. For example, the people who come into a Hadoop course might not be from a Linux background, but here I think it is not the case. But still, they are most welcome with any questions. I have set up my DNS as well, right? I'm running my DNS. So if I say hostname cat slash etc resolve.conf, right? And I say ns lookup on this, right? It will give me an IP. Also, if I do a reverse lookup, it will return me the host name, right? I have set up, as I told you, as near as production. So when we start doing the classes practicals from tomorrow, we can take things one by one and all, but I can show you a few things, right, today itself. Now, another box. As I was showing you, there are so many boxes I have, right? But currently I've started one box, and then one I'm calling name node 1, data node 1, data node 2, data node 3, right? So 3 data nodes I have started, right? So let me show you what does this mean. Okay, cat slash ns lookup and then 1, right? See, my name node is at 70, data node is at 72. Okay, what has happened here is my bridge interface is different. I'm on Ethernet, but I've given my Wi-Fi because I was doing something on my lab by using Ethernet. Okay, let me change it to Ethernet quickly. Data node 3, network, Ethernet, right? So I will show you what all these options are. Just bear with me for a moment. Now I connect to my name node. Host name. This is my machine which I am using as name node. 72 I'm using as another data node. 73 I'm using as another data node, right? Now, so if I do JPS here, so what is JPS? Actually, it's a Java process command, right? Similar to a PS command, right? So you don't need to worry about the details now, but I'm just showing you a feel of Hadoop cluster. Right? So now I have 3 data nodes, 1 name node. CD Hadoop, right? So I have set up Hadoop here. CD Hadoop ls-l, right? I have files here, cd config, some files here, right? So now I say Hadoop -daemon.sh start name node. I can do one by one, or I can simply do start-dfs. Don't need to worry about this. We will be setting up all this. So I'm just giving you a glimpse of my cluster. I do JPS, you will see name node is up. If I go here on data node and I do JPS, you will see a data node up, right? So how we have configured this, how they are working, talking, right? That's a different thing. Hadoop fs-ls. right? Similar to ls command, I'm doing a Hadoop ls command also. cd, okay. Okay, Hadoop fs hyphen ls. So you see n number of files which are on my Hadoop cluster. So let me just delete them so that it is easy for you to read. Right, so it is saying currently deleted, empty. Now let's look at the concept. So I'm saying name node nn1 dot dilithium, some domain, right? JPS name node is running. ls-l local file system. Let's create a file. vi from nn1. I'm creating a simple text file. This is text file, right? Let me see anybody has any questions in the meanwhile. Okay, no questions. Okay, so I'm creating a simple text file. The file is on my Linux file system, native file system, right? Simply I created a touch command. Hadoop fs-ls. Anything which I proceed by Hadoop keyword and fs, it becomes a Hadoop command, right? The command is ls only, but now it is executing on Hadoop. It does not have anything. Now I say put this file, which file? From on Hadoop. Gone. Now this file is on Hadoop. I can cat also. I can cat this file from underscore nn1, right? I can delete the local file so that it does not cause confusion that where the file is coming from. I do not have this file locally. This file is on Hadoop file system, right? Now, I was explaining you the concept that the metadata goes on name node and data goes on the data nodes. Let me close so many tabs I opened. Right? JPS. You see a data node running. Let me log to one more data node. How we are set up and all that, we will be covering all that. Do not worry about that. All the details, how they talk, how we have configured, how they, why they are able to talk or how they communicate, all those things we'll be looking at. 23, right? JPS. I have three data nodes. 1, 2, 3, one name node. How I can be sure? I can also say this command, right? So you do not need to worry about this command also for the time being, but I'm just showing you when I'm running report command, right? Which is a kind of a report of my cluster. It is telling me the total capacity of my cluster. It is saying three data nodes I have, D1, D2, D3, right? These three nodes now, right? Now, What if I shut down my data nodes? Let me show you. Stop data node. Now this daemon will not be there. JPS, this daemon is gone, right? Now I execute the same command on all three nodes. My data nodes are gone now. JPS, JPS. I'm sitting on name node. I do Hadoop fs -ls. I still see the file. What I see, the metadata of the file, because it is stored by name node. This is what I was explaining. What name node stores? Name node stores the permissions, who is the owner, what is the size, group, timestamp, and the name, right? But the moment I try to read it, if I say cat, it will give me error, because now it is saying data nodes are not there. But I can list the metadata. So now metadata is separate, data is separate. Now let me quickly start back. Currently I'm stopping all three because I don't want to get you guys into complexities in the very first day, but we can know where that file went. I did not need to actually stop all three. We can know where the file went, which data node the file went, right? We'll look into that details. So now I've started all three data nodes. I do a cat again, file will be here. So this is what this is explaining. So I cannot do any sort of read operations or a write operation on a data node. If my data node is not there, I can list the metadata. Now, as I was explaining fs and all, I'm sitting on name node ls-l/data name node current. See, this is what I was explaining you. We will look into detail of all these files. On the name node, it will have these journal files, edits, and this is the actual fs image. So whenever we are doing a write, it is actually going into this journal, and it will be only committed either through a checkpoint or whenever we restart the name node. All these file has a meaning, version file and all these things, we will look into that. Now let's go back to the slides. So this is what I was explaining you. So what things you need? Virtual machine, right? Let me quickly give you a demo on the virtual machine also, and it will keep on installing side by side, and we will do something. So let me give you a demo. So as I said, any Linux machine is fine, whatever you are comfortable with. I use CentOS because this is what it is used in production, either Red Hat or CentOS. So I prefer CentOS. So I say new, any name I give. Let's say test. It's a Linux. I say Linux. Which Linux it has? So CentOS, for example, it is not listed here. So what I can say the kernel and 64-bit. I say continue. How much memory I should give? 1 GB, right? But I can run it at lesser also. But to quicken the installation, I'm giving it more. Let's increase to a little bit more. Continue. Create a virtual hard drive now, or do not create a virtual hard drive. So I'm saying create a virtual hard drive. I'm using a second option. Which of the hard drive types you will choose? Right? So I'm using VirtualBox. So if you go and search on Google here, uh, VirtualBox download. It is free. It will point you to Oracle. You can go download it. Depending upon your base operating system, whether it's Mac, Windows, whatever, you can download it for even for Linux. Now, I can either choose the image type of my virtual machine to be either VDI, which is a native VirtualBox image format. I can increase, decrease the size of this volume afterwards also, even after installing the operating system. I can use VMDK, which is virtual machine disk. What does it mean? I can use the same disk in VMware also. I might have created that disk by VirtualBox, but I can import it to VMware workstation as well. Right? Choice is yours, but I cannot dynamically change the size of disk. Right? Parallels from Microsoft and all other versions we have. So I prefer VDI because I can dynamically change the size according to my need. I say continue. Now, second thing comes, do you want the size to be dynamically allocated or fixed size? What does it mean? Let's say if I continue and if I give 8 GB of hard drive and if I say fixed size, it will create 8 GB file immediately for me. Means it will take some time and my base system will now start showing 8 GB less because this file has been pre-created. But if I say dynamically allocated, what it will do, I'm saying 8 GB maximum, but it will expand as I write. If I write 1 MB, 1 MB, 4 MB, it will be expanding as I write the disk of the virtual image. This will be little bit slower. Dynamic will be slower because the moment I'm writing data, that time the file system is expanding, right? Not a problem in test environment, right? Go by the dynamic method. The location where you want to store, it's your choice. Then I say create. Immediately it did. If I would have choose fixed one, then it would have taken some time to create a 8 GB hard drive. Now, I can either right click settings or I can go to settings at the top. Any name, I can change it now. System tab, memory I can change afterwards also, right? Boot order, where this system should boot. Floppy, we don't have anymore. Let me move down the order. I'm saying first boot device CD, second hard drive. Processor I have mine is i7 with 16 cores, right? So it is, that's why it's showing that. It's your wish how many cores you want to give. I give 1 core, 2 core. Video memory, no need to change anything. Storage I've already given, right? CD drive, do I want to give the physical CD drive for installation, right? Or I can give a virtual ISO image also, right? So let me just show you where it is. I go to softwares. I have 6.5, 7, whichever you are more comfortable. If you are not from a Linux background, do not go for CentOS 7 because it has a little bit like system CTL and system daemon and all that, which are a little bit complex. Not from Linux background, go for CentOS 6 version. I select that, your wish, RHEL server, Ubuntu, what you want, select that, open. Now I've given the image. Network. Let me see any questions I have. No questions yet. Network. What network I will give? My choice. But if I give NAT, what is NAT? It is network address translation. My base machine, which is Mac, and how this virtual machine they talk to each other, it is decided by these parameters. If I say NAT, it will do a translation table. I have to write a NAT rule to for the nodes to communicate. I can go to internet, not a problem, but to talk to my base machine I have to write a NAT rule. Second, I can use, for example, host only adapter. In this case, I will be able to talk only to my base machine but not internet. I cannot go outside. Best is bridged adapter. What does it mean? I'm saying bridge my virtual machine's network card onto the network card of my base machine. Which network card? I can choose Ethernet. As you might have seen, I just manually changed it. Ethernet, or I can say Wi-Fi. So I'm saying Ethernet because it is currently in use live, right? I say okay. Now I power on my machine. So I'm giving a demo so that before tomorrow's class, I do like, it's not that while I'm giving demos you have to do side by side. You can practice at your own time, but thing is, it will be good because after the class you want to practice or before the class you want to practice, keep your labs ready, right? So you don't need to configure anything during the class time, right? You just have to watch. Just I'm doing skip because I don't want to check the file system. I'm fine because it's an ISO. Skip. It's installing. Next. Language. Keyboard. What is your storage type? I have my very simple storage, right? We just created a virtual disk. I do not have any special storage. iSCSI. I do not need to do any kind of storage mapping or any fiber channel. I don't have. I say basic storage. So it's checking. So the disk which we have given was 8 GB. It is saying I found a disk. Are you sure you want to remove the data? Keep data. Discard any data. Host name test.cluster1.com. Your wish. Whatever name you want, you can give. Configure network. I will give it an IP. What IP I will give? Either I will give dynamically, because let's say you are attending this webinar session. So obviously you will be connected through internet, and at your home you will have a router, maybe a Wi-Fi router or some other kind of a router, right? Which will dynamically give you an IP. You can select automatically IP, your virtual machine will get an automatic IP. But problem will be it will change the time you reboot it, right? Depending upon the DSCP lease. So your IP might differ every time, which I don't want. So I can statically give a manual IP. I'll say manual IP, add, and I'll say 192.168.1. Any IP you want. Let's say I say 33. Net mask, your subnet mask 24, which is 255.255.255.0. Gateway will be your router address, means whatever router IP you have at your home of your router, that one you will give. DNS server 192.168.1.1 if it is your router DNS server or whatever your DNS server is. In my case, I have my own DNS server, so I'm giving 254. IPv6, I don't want. I say apply. Okay, question from Shiva is, whenever we need a file to be created under HDFS, that must be done only on name node, or we can create file on data nodes. Okay, I will come to that. See, this I was just trying to explain you from the concept of metadata relation and the actual data relation. But in a real case, data is never going to name node, right? If you look, name node is only storing metadata. Actual data is always going to a data node. And in a production environment, what will happen? You will never be allowed to SSH, means to connect to a name node or a data node ever. You will be given a gateway node, which is called a client node, from which you will connect to your Hadoop cluster. So we will do that also in class, right? We'll set up a client node, which will not be running Hadoop, which will not be part of Hadoop cluster, but can talk to your Hadoop cluster. So all users will be only given access to your client node from where you will do all your copy operations. So as your for answer for your question, short answer, data always goes to a data node, never to a name node. Only metadata goes to name node, irrespective of wherever we create the file from. Right, so I've done this. Close. Next. Time zone. Calcutta, some password you gave. Whatever password you gave, remember it. How you want to partition your disk drive. All those who are not from Linux background, do not know about how to create a file system, just select use all space. Next. Write changes to disk. So now from this point onward, I cannot revert back. If there was some data, it will be gone. Now the option comes, what I want to install. I want to install a desktop, mean it will give me a graphical interface where I can use my mouse. I want a minimal desktop. I prefer minimal setup, right? Not even a desktop. But if you are not from a Linux background, you want to use a mouse to do something from your interface, right? For example, let me show you. Right? So this is your virtual machine. Right? In this, you can log in and use your mouse and all that, but I'm not doing that, right? So minimal desktop. Next. It will start installation. Okay, let it start copying file. In the meanwhile, let me come back to slide and ask you few questions which we can use for tomorrow's class build up. So now question is this one, metadata. I was telling that everything, all the metadata of a cluster goes to name node, right? I was saying name node is the one which will decide the size of my cluster, right? If I say my name node has RAM 1 GB, I can have X number of nodes, right? So your homework will be find out how this is a limiting factor. Obviously, I have told you that all the metadata resides in the memory. But let's say somebody says, I have 1 GB memory on the name node. What can be the size of my cluster, right? Just read it. Search on Google, read it. I will explain you this tomorrow. But let me give you a explanation of this. Very fundamental explanation, which you will not find in blogs, and you can think on it. Hadoop is written into Java, which is an object-oriented programming. Oops, concepts. So in Java, we treat everything as an object, right? Object-oriented programming. In Hadoop, everything is an object. What does it mean? A file is an object. A directory is an object. A block is an object. Everything is an object. Now, what is a block, first of all, right? Let me just quickly explain you, because I think all Linux guys, they know it, but for the sake of the other people in the audience, let's say I have a file. Let's say 1 MB file. Let's say Linux first. Let's understand Linux Windows. I want to write this file to hard drive. So obviously 1 MB file will just not go and sit in the hard drive in one location, right? On the hard drive, you will have smaller sections, partitions, right? Tracks, sectors, right? Which will decide your block size, right? So let me show you. The diagram was there in the disk somewhere. Yeah, this one. On disk, you will have these tracks. Each track will have a sector. Now, the size of the sector is standard, means how big this sector will be. This is industry standard, which is 512 bytes, right? How many sectors I have per track or how many tracks I have per disk, it will vary from manufacturer to manufacturer, right? For example, some manufacturer might have high density disk drives, means they have put many number of tracks in a smaller given unit of area, but the size of the sector will always be 512 bytes, means that is the smallest allocation unit possible. Even if your file is 1 KB, or even if your file is 1 byte, minimum it will occupy 512 byte on your disk. This is the smallest allocation unit. So what I can do is, my smallest allocation unit on disk is 512 bytes, right? This is a sector on your physical disk, smallest unit. So now when I'm creating a file system, any file system, ext3, ntfs, fat, people in the audience are not that old, so they might not be knowing fat 12, fat 16, all those things, right? But all these were also file systems at one time. So now whenever I create a file system, I have to optimize, right? So what I optimize, I will say how big my block is. Block is a kind of a logical abstraction from a file system perspective. I can either combine one sector as one block, or I can map one block to group of two sectors. In that case, my block will be 1 KB because it is mapping to two sectors. I can make it a group of four blocks, 2K block. Obviously, I cannot make three because the formula is 2 to the power n, right? So blocks can be block 512 bytes, 1K, 2K, 4K. It can be bigger also, 8, 16, 32, but not on Intel architecture. On any architecture which is x86 Intel architecture, irrespective of the operating system, whether you are running Windows, Linux, 32-bit, 64-bit, does not matter. The largest block size can only be 4 kilobytes. Can anybody tell me the reason why that is so? Why on an x86 Intel system my largest block size can only be 4 kilobytes? Let me see. In the meanwhile, install, where have the installation reached? Okay, it's still going on. Anyone? Okay, not problem. So the reason for that is it has to match the page size of your Linux or page size of your hardware. On x86 system, my pages are 4 kilobytes in size. So when the pages are swapped in or swapped out, the smallest unit which can be paged in or paged out is 4 kilobytes. So that's why on the disk also we have 4 kilobytes, right? I can have in Spark, Intel, Titanium, HPUX, those boxes I can have bigger block size, but hardware is different. That is not x86 Intel, right? So my block can only be 4 kilobytes. So now block is a combination of sectors, a group of sectors. Now in the case of ext3, ext2 and all, my file systems are very blocks are very small. As we saw, 4 kilobyte is the largest block size I have. In Hadoop, when we come to Hadoop HDFS, by default your block size will be 64 megabytes, right? What does it mean? I will install a Linux box as we are installing. I will create a file system, native file system, ext3, ext4, whatever I create of my Linux system. On top of it, I will create an HDFS file system, right? My Intel platform does not allow me to create a file system with larger block size than 64 KB. But on top of file system, I will create a pseudo file system, which is HDFS, which will have block sizes much bigger. 64 megabyte, 128 megabyte, 256 megabyte, 2 GB, your wish. But by default, it will be 64 MB in Hadoop 1. In Hadoop 2, it is 128 MB, right? We'll go into detail of that. So now what happens in HDFS? When I'm creating a blocks of 64 MB, so what it is doing is, let's say I have an HDFS block. This is 64 MB. And obviously it is anyway sitting on top of ext3 native file system, right? Whose blocks are 4Ks, 4K blocks. Right? These all are 4K blocks. So whenever I write a 64 MB blocks, 16,000 parallel operations happen on the lower file system in sequential. So that's why it is able to write that much data quickly in file system. Why 64? 64 MB divided by 4K bytes. So 16,000 parallel reads will happen at the lower file system level, and they will be sequential. Means all the blocks will be on the sequential disk, not random read write. So now this is a block, right? So now coming back in Hadoop, as I said, everything is an object. A file I create is an object. Any directory I create is an object. Any block I create is an object, right? So each object occupies 150 bytes in the memory of the name node. Because when I say inode structure, obviously inode has to load into memory. It will occupy some memory, very small in bytes, but it will occupy. File will occupy some memory. Directory object will occupy some memory, right? Each object occupies 150 bytes of memory, correct, in the memory of the name node to represent it. So for example, if I have a file 1.txt whose size is, let's say, 128 MB in size, I write that to HDFS. What will be the memory, minimum memory used by the name node? Minimum memory, I'm saying, right? Memory can be more, we will see that replication and all, but currently we are not considering. I'm taking the best case for the calculation. For one file name metadata, 150 bytes plus file size is 128 MB, default is 64 MB. So this will be broken down into two blocks, each block taking 150 MB. So 300 bytes for block. So total 450 bytes will be needed in the memory of the name node just to represent one file which has two blocks. Correct? So now I will divide the total memory which I have available on my name node by this factor. So the best practice is, for every 1 million blocks, I need 1 GB memory on my name node, right? So now homework for you guys is, when I say 1 million blocks, can I say how many data nodes I can have, or how many nodes I can have in the cluster, right? Let me explain you what I mean. If I have name node, let me see whether the installation is done or not. Okay, installation is done. I will quickly reboot it and my box will come back, right? So after the reboot, what important things I have to do? Disable firewall, disable SC Linux. Two things I have to disable. And my box is up, and we will start with the installation part. So from tomorrow onward, we will see Hadoop, right? From the installation perspective. Let it come up. I will quickly show you what has to do. We have to do here. So I have a name node. Let's say I say my name node's memory can support, let's say, 1 million blocks or 1 million files, let's say. Now, how will I say whether 1 billion files are coming from 4 data nodes or just from one data node? For example, I may have 4 nodes, each having 250 GB of hard drive, correct? Total data is 1 terabyte. So I can, let's say, load 1 terabyte of data in 4 nodes. Other case could be I have a single server which is having 1 terabyte hard drive. So now our theory is wrong, which we are saying that if I have one memory, my cluster can be 4 node. No, it can just get out of memory in one node only, because it will depend upon how many blocks we advertise from a data node, right? So the statement we say as a, let's say, a Hadoop person, that my cluster will be 100 node, 1000 nodes, but that calculation is based at the background this formula. So let's say in my company, if I am running a 10 node cluster with 1 gig memory, it does not mean in another company in 1 gig I can run 10 node cluster. No, his hard drives might have much more capacity. It might run out with just one node, right? So all these things. So please do read on this and understand what it is, right? Very important to understand. Now let me quickly see. Okay, it is up. I say next, agree the license agreement. No, I don't want to create any user. Time, date, everything is fine. Kdump I do not want. Finish. Right, now my machine is up. So I can use mouse here to log in, your wish, or you can simply go from the command line also. I'm like, if I go and connect from my command line, IP I have given is 33. I say yes. Red Hat is the password I have kept. First thing I have to do is service IP tables stop. I do not want firewall. I can disable it. IP tables stop. Oh, sorry, off. So I do not want it to come back. Second thing, vi etc sc linux config file. I have to disable sc linux. I will say from enforcing to disabled. Disabled. I will just disable it. Right? And my sc linux is disabled now. Hostname is fine. IP is fine. Everything is fine. I just simply reboot the node. Init6 reboot, but currently I'm shutting down, and everything is ready for my Hadoop, which will do it tomorrow. So you can set up your virtual machines. Okay. So this is what we done. So enough of an introduction. So we'll do a technical deep dive from tomorrow's session. Right. So this is what I've talked about. So important things which you need to refer is these blogs I've given you. Please read through Michael Knoll, very good blogs. PDFs are available. If you search on Google, easily available for download. Hadoop Definitive Guide, Hadoop Operations Best Book. Best way to learn Hadoop, follow the bug tickets. Jira, right? Like Hadoop, if you go on these links, you will see what issues, what tickets, what enhancements has been filed. Another is my GitHub, right? So let me show you my GitHub. So this is my GitHub, which I'm talking about. Let me just share with all. I have sent to all in the chat. You don't need any username password. Just hit this link. All things we cover in class, even more than that, right? Everything is here. For example, how to set up DNS, installation steps, config files, zone files, how to set up Hadoop each config file I have uploaded here, what parameters goes, everything. So we'll be using this in the class, so you know where each file is. So you don't even need to bother about noting down the config files which you have modified. Just go there, download it, right? And you can clone it if you want. You are most welcome to do that. No, not a problem with that. Further reading, please read through these things, these blogs, if you get time, because tomorrow we will be mainly starting with Hadoop, right? Today we have just built a very fundamental base. Tomorrow we'll be seeing how to set up cluster. We'll start one by one. First setting a single node cluster, then going towards a distributed cluster, setting multiple nodes, and we'll do a deep dive into HDFS file system, right? Like she was asking where the file is going, name node, data node, right? We will look into that, where the file goes, how it is knowing where should I copy the file, right? All these things, right? And how they talk to each other. We will also look at what is replication and how it plays a role, right? So please read these things before the next class. So any questions you have, probably you can ask me. So today's session was very brief and introductory, but we will start doing deep dive from tomorrow's class, right? So please get all your tools ready, like install a Linux, VMware, whatever you want, so you can play around what classes we are doing side by side. Okay, so if there are no further questions, then probably I think we can close today's session. And I will send out these PPT in email, this presentation in email, and also each session, like today was more of an introductory, so there was no assignment or anything. I will send out an assignment also with each module. This session is recorded, like all sessions will be recorded. So I will upload it and I will share you the link, right? Maybe in 2 hours or 3 hours, you will see an email from me with all these details, where to go and download the videos and all. So I hope it was a good beginning for everyone in the audience. And as I said, as we go along, so we will be mainly talking about Apache Hadoop. As I said, the main learning happens if you do things manually. You should know each file, what it does, where each parameter goes, why we have kept it that way, right? Because if we go by Cloudera, Hortonworks, and all those things straight away, those are tools, graphical tools, which will hide a lot of things from you. Why things are working, you will not know, right? Forget about troubleshooting, right? I'm saying even the things are working, you will not know how it is working, where it is writing what. Once we are through with all the concepts, right, each file we understand, we look at parameters, what they do, then we can pick up any distro depending upon audience poll. Let's say they work Hortonworks, Cloudera for a demo, we will do that in the last sessions, right? Not now, that is too far currently. Okay guys, so thanks very much for your time, and I will see you tomorrow at the same time around 8. So I think all people have already registered, so there will be no problem tomorrow. Thank you very much everyone, and have a nice day. Bye bye.